The mass of a supermassive black hole sitting at the center of a massive is responsible for when it stops forming new stars, a new study has found. This could explain why young galaxies are a hotbed of star formation, and why that process slows down and eventually stops completely as they evolves. The presence of a supermassive black hole at galactic center is mostly inferred by the gravitational effect it has on these stars. Sometimes, however, it can also be observed by looking at the energetic radiation from the active galactic nucleus. Simply put, the energy radiating from the AGN could be responsible for heating and dissipating the gas that would have otherwise cooled and condensed into stars. In case you were wondering what exactly an AGN is, it is the compact region at the center of a from where the intensity of radiation across much of the electromagnetic spectrum is much higher than the rest of the. This radiation is thought to be produced when the supermassive black hole in these center stars to accrete matter. The idea of an AGN disrupting the formation of new stars is new, in of itself. But the theory had been lacking any observational evidence that Ignacio Martí-Navarro, a postdoctoral researcher at the University of California, Santa Cruz, and his colleagues behind the new study say they have. The study looked at massive galaxies, the mass of whose central black holes was already known, were established by analyzing the motions of stars near the galactic center. The history of star formation in those galaxies was looked at by the researchers, by analyzing the spectra from those galaxies. Differently aged populations of stars show different data on the spectrograph. This illustration from NASA shows a black hole with a disk and a jet. Photo NASA Caltech, for galaxies with the same mass of stars but different black hole mass in the center. Those galaxies with bigger black holes were quenched earlier and faster than those with smaller black holes. So star formation lasted longer in those galaxies with smaller central black holes, Martí-Navarro said in a statement Monday. The only factor that seemed to have a role to play was the mass of the black holes, with the size, composition or other properties of the galaxies themselves not being important. We used black hole mass as a proxy for the energy put into by the AGN, because accretion onto more massive black holes leads to more energetic feedback from active galactic nuclei, which would quench star formation faster. Martí-Navarro explained. AGN could be used as proxy because they are highly variable in general, with their properties depending on the black hole's size and the rate at which it is accreting matter, among other factors. Gene Brody, professor of astronomy and astrophysics at UC Santa Cruz and a co-author of the paper, said in the statement, "This is the first direct observational evidence where we can see the effect of the black hole on the star formation history of the research also involved scientists from other universities in the United States and Europe, and was published Monday in the journal Nature.